Hi, in this video we're going to look at the charge to mass ratio experiment that allows us to investigate the charge to mass ratio of an electron. We do that using the following equipment, consisting of an E/M tube, which is basically an electron gun inside of a glass bulb full of helium, the Helmholtz coils that surround it, and also the power supplies that are required to power the whole thing. We do have two different power supplies and they're just on the screen at the moment. So briefly, I'm just going to quickly go over the two power supplies as this is important for running this experiment. They are slightly different to each other, but functionally do operate in much the same way. Now, the first power supply that you can see on screen at the moment, it's one of the newer ones, so as a result, it's actually designed for this experiment specifically. It only goes up to a maximum of 200 volts, and there's a dial that's highlighted right now that allows you to adjust it up to 200 volts. And on the bottom, you control the current to the Helmholtz coils. The voltage is already set for you. You don't need that value anyway. For this power supply, it's a little different. As mentioned, you do need to adjust the voltage and the current for the Helmholtz coils. That's done with the dials at the top. On the bottom, to adjust your voltage for the electron gun, there's a dial there labeled 500 volt adjust, and that's currently highlighted. You don't adjust the current to that, but you do use the dial to adjust the voltage. And again, you want to make sure that you're careful not to go too much over 200 volts, as you can damage the setup as a result. The setup does also have a shroud just to block out some light. Now, the way this experiment works is that you have your electron gun and it fires. Then as we increase the power going to our coils, that's going to start to deflect the beam, just as you can see in the little animation in the background. So, this is recorded in the dark, and I do realize that makes it a little difficult to see what I'm doing, but bear with us. So, what I'm doing in the video at the moment is I'm increasing the voltage to the electron gun up to 200 volts. Now, it's okay if you go a little bit over that, just don't leave it too high over that value, like 203, 205, something like that, that's fine. Now, without the beam being deflected, it just goes straight across. There's nothing influencing the beam. If you had a permanent magnet, you'd be able to move the beam with that. Now the next thing I do is I start to provide power to the Helmholtz coils themselves. I go up to about 9 volts, 2 amps. That's the maximum value that I run the experiment at. Your instructions do have a bit more detail as to your maximum possible values for that. But you can see here, just similar to the animation, that as I increase the power to the coils, the ring basically reduces in size, it contracts, it's deflected inward, that beam of ionized helium. We'll just move the camera in a bit closer here, just so that we can actually see the ring itself. So here you can see the ring that's formed. It's quite narrow, or quite small, and behind it there's a mirror that we use to take the measurement. Now to take the measurement, what we can see here is there's a mirror above that ruler, and in order to eliminate parallax, what you do is you line up the beam with its reflected image in the background. You then would basically do this for the left and the right, and the difference between them gives you your diameter. In this case, the measurement I got here was roughly 5 centimeters. Now one thing you might see going back and forth between the two between different measurements at different voltages, you might see these measurements fluctuate a little bit. Some measurements might seem higher than the previous in terms of the radius. Like the trend that you're expecting to see isn't perfectly linear, or it doesn't go up or down. That's fine. Just in the video at the moment, what you can see I'm doing is adjusting the ruler, and the purpose of that is for lower power provided to the Helmholtz coils. The circle's obviously bigger, so you have to adjust the ruler in order to get those measurements. Now, again, you can see here that what I've got set is about 200 volts, about 9 volts to the coils at 2 amps. And what I'm going to do is I'm just going to adjust my current. Now, again, we don't really care about the voltage, applied to the Helmholtz coils, and we're not overly concerned about the current provided to the electron gun either. So here I just drop the current, I'll drop it to about 1.5 amps. Now, without directly seeing, you can't see that I've done anything there, but we'll just do that again. And this time you can see as I adjust the current back and forth, the circle grew and shrank accordingly. So here, what I'm doing now is I'm adjusting the electron gun voltage down. I'm dropping that. That's one of the two things you will adjust in terms of your voltage and current. I've also returned the Helmholtz coil back to my original settings of about 9 volts, 2 amps. And basically what you're going to do for your measurements is you're going to get a series of current measurements for each fixed voltage of the electron gun. So I started with 200 volts. I'd get a couple of different measurements, say at 2 amps, 1.7 amps, something like that. And then I do that again for another voltage. And you can see here I've got a slightly larger ring once again. I'd have to adjust the mirror to try and get an appropriate measurement. And do keep in mind, of course, that this is now 2 sources of error straight away. Another thing you can sort of see in the background right now or in the video is the beam appears to be spiraling off into the distance. There is a little plastic adjustment ring on the bottom of the tube. Basically, if you do see it doing that, all you need to do is rotate it back around, and that should bring it back circular. One final thing to remember, when powering this experiment down, make sure you do slowly turn down the voltage of the electron gun, don't just turn it straight off.